Hi, I'm going to introduce my paper for Body and Society called Hearing Gloves and Seeing Tongues, Disability, Sensory Substitution and the Origins of the Neuroplastic Subject. This is for a special issue, Symmetries of Touch. So what is my paper about? Well, in a few sentences, this. Researchers in post-war industrial laboratories, such as Bell Labs in New Jersey and the Smith-Kettlewell Institute in San Francisco, pioneered solutions to compensate for sensory loss through so-called sensory substitution systems or sensory substitution devices, which were premised on an assumption of cortical and sensory plasticity. Now, my paper plugs into these early discourses of plasticity in the psychology literature, starting from William James and the Principles of Psychology, which was acknowledged but not really developed by Norbert Wiener, but expanded upon explicitly by the Mexican-American experimental neuroscientist Paul Bach-y-Rita and his collaborators. Cumulatively, my paper underlines the crucial yet underexplored history of research on sensory impairments in the discovery of underlying neurophysiological processes of plasticity and what I call an emergent discourse of neuroplastic subjectivity. What are sensory substitution devices? Well, as some of you know, they're used in medical rehabilitation and physical therapy for those with severe sensory impairments, deafness or vision loss. These devices supposedly enable the subject to see or hear through other means. Now, a recent instance of a TVSS that I expand upon in the article is YCAB Corporation's Tongue Display Unit, or TDU, typically portrayed in media coverage as allowing blind test subjects to see with the tongue, enabling them to visualize shapes, read words, and walk unaided, in the words of a newspaper article. Now, philosophers as well, such as Alva Noe and Kevin O'Regan, have specifically featured SSDs as case studies to make larger claims about plasticity and the underlying neurophysiological architecture of the brain, but also to argue for a specifically sensory motor theory of embodied perception. Since there's a process of adaptation to sensory translation between vision and touch in SSD test subjects, some neuroscientists and philosophers deem the case of tactile-visual sensory substitution especially as evidence of cortical plasticity. One of the chief pioneers of TVSS, the neuroscientist Paul Bach-y-Rita, observed this phenomenon in a 1967 paper and also repeated this shortly before his death in a paper from 2003 when he said that sensory substitution is only possible because of brain plasticity. And to do that, I'm going to use two case studies. Well, actually, there's three in the paper, but I'm going to talk about two right now. One of them is after discussing the conceptual foundations of the principles of sensory substitution and the history of this in philosophy. That's in the first part of the paper. I go on to two laboratory-based examples. First, Project Felix. Now, Project Felix was an experiment in vibrotactile communication by means of hearing gloves for the deaf at Norbert Wiener's laboratory at MIT, and was demonstrated to Helen Keller in 1950. This was what Wiener called a sensory prosthesis. The hearing glove was designed to transcode human speech into tactile data for the hand, so to kind of hear through the hand. And the second example is going back to the TVSS, tactile-visual sensory substitution system for the blind, pioneered by Paul Bach-y-Rita from 1968 onwards. And towards the end of the 20th century and the beginning of the 21st, this has led to more portable, reliable, marketable, and FDA-certified instances of sensory substitution devices, including the BrainPort and the TDU, or Tongue Display Unit. And here you can see a test subject with an electromechanical device from the 1970s, starting off on the back and then tried on the abdomen. And here you can see me trying the tongue display unit a few years ago at the University of Pittsburgh Medical Center. So finally in the paper, in a section called Neuroplasticity and Sensory Substitution, I return to the concept of neuroplasticity for a more detailed discussion of the kinds of plasticity involved in an experimental subject's adaptation to these devices, and I consider what implications there may be for those with or without sensory disabilities.